Hey everyone, my name is Trevor Spires, and today I've got a quick video, something that I probably should have done a long time ago. I make a lot of content about Avi, which is VMware's advanced load balancer, and I haven't made a really good video explaining why exactly I think Avi is really the best enterprise load balancer that you can get today. It's not just because I am employed by VMware. That is definitely how I was introduced to Avi, was through the VMware acquisition that happened a couple of years ago. But the reason I work on the Avi team, in fact, after VMware acquired Avi, I requested to and was moved over to the Avi business just because I'm such a big believer in the product. I really think that uh, as somebody who has gone through the challenges that maybe whether it's a developer or an engineer who's managing maybe an F5 load balancer or an Nginx software proxy. I've been in the shoes of the engineers and operators that have that as their kind of daily life, and to me, Avi just has a really clearly better consumption model and user experience, and frankly, architecture as well. So I'm going to walk you guys through really why I think that if I was buying a load balancer, this would be my number one choice like 95% of the time right now. So first and foremost for me, it's the install and configuration. So the first time I installed Avi, I got it installed very quickly, and all of that was because Avi automates for you the various APIs that it integrates with. So whether it's Amazon or Azure or Google, vSphere, even NSXT, if you want to install an Avi load balancer, you do not actually have to install a load balancer. You just install this one controller, this one OVA, or this one image on Amazon. And after that, the full life cycle, whether it's an upgrade or deploying a new load balancer or expanding into a new environment, all of that is fully automated by the controller, which is a huge, huge time saver. It's not, I work with engineers. It's not that engineers aren't smart enough to automate the provisioning of a load balancer. It's that there's just a better way to spend your time. And so I think you could spend years, weeks, months building this custom pipeline and testing it to make sure that the load balancing deployment is automated for you in this kind of roll your own way, or you could have a solution that just does that in a supported and integrated way through a single API endpoint, which is what I would prefer if I were building out a complex solution like that. In addition, just the basic configuration workflow is very, very standardized, very templatized, and to me, very intuitive because it's just a modern UI that was built in the last decade. We have the full end-to-end path. So from a single view, I can see the VIP, some behaviors on that VIP, whether it's like a content switch or something like that I'm doing within that application, as well as the various back-end pools. Maybe it's one pool, maybe it's multiple pools. I can see that all in a single view without having to click all over the place. And again, it's a small usability enhancement that had made a big difference for me as an operator that it just kind of was like, wow, why hasn't anybody else done this yet? Was my takeaway of just these kind of basic usability features that should be in every product. The installation was like a wow factor for me when I learned it initially, but then what really got me deeper into this ecosystem was the continually just excellent operator experience that I was delivered. Just for starters, right? A big piece of that operator experience is the analytics that Avi provides. If you know anything about Avi, you've probably seen this already. I'm not going to do a full demo of the analytics for you right now, but basically we break down and give you a perfect picture of the end user experience. When you sit in the middle of an application as a full proxy, especially as a full L7 proxy, you can collect a lot of data relevant to the performance of your application because you sit in the data path. And that's what Avi has done. We sit in the data path as that proxy, as the load balancer, as the ADC, and we send all that information back to the controller so you can find out what was the end user experience at any given point in time. Because as we all know, the end user experience may change, right? It may change because there's a performance issue or there's an outage or there's some problem. To be able to go back in time, up to a year and figure out what the end user experience was at any moment is really valuable, as well as being able to understand if that issue is happening at the network layer, at the application layer. Maybe it's at the server layer, the load balancing layer. There's a lot of different layers in the data path that an issue can happen at. And Avi makes it really easy to determine with this easy color coding fashion of exactly where that issue took place. All the analytics and the graphing are backed by logs. And oh my gosh, I wish I had time to walk you through a full end-to-end logging and analytics demo for Avi. I do not, but all I really want you to take away from this is, every transaction, you can either get all the transactions or a sampling of a certain percentage of the transactions depending on your app. You're going to get a rich set of data. You can search on that data. You can parse all the sessions. You can look at exactly what's happening, what the load balancer is doing to that packet, whether we're adding or removing headers from the packet, whether we're doing a content switch, or whether there's a WAF applied. There's anything that the load balancer is doing to the packet, or even if it's just the expected algorithm of load balancing that packet, we're going to log here and allow you to troubleshoot issues. And customers that I work with are finding much faster resolution of trouble tickets using this method. In fact, I've had some customers that have installed Avi on a faulty application and were able to fix what was wrong with the application. So they were able to, in an F5, they had a problem. So they were able to install Avi, put it in front of the application, see the analytics, identify the issue, fix it. And then for them, it was a clear thing like, wow, we've had this issue with our application on an F5 for weeks now. And it was an obvious move for them to want to switch to Avi because they saw the value really quickly fixing one app. And they knew that by going with something like Avi, who has these analytics just built in, they would always be able to do that. And that's an important thing. I think the people who designed this product are very smart. I think that they intentionally made it enjoyable for the operator, right? There's a lot of usability benefits, whether it's getting a PCAP, whether it's configuring a basic VIP or a content switch policy. The interaction that an engineer or operator has with this load balancer is just more fulfilling. You're getting more work done when you're logged into the interface or when you're manipulating the API, which I think is why it tends to be when an organization or a customer starts using it, it grows naturally over time because we reward you for the use of the product with the logs, with the monitoring, with the automation, to ultimately make your life better. So you'll hopefully come back and continue using the Avi platform. That's really the only goal. Okay, and to me, the final thing I want to highlight here is the scale, architecture, and integrations. Really, I could just summarize that and say architecture, because the architecture of Avi is pretty unique, and it's what enables a lot of the benefits that I've been talking about so far, okay? Particularly, what I mean by the architecture is it is a controller-based solution. So that means it's centrally managed via a controller. This controller is the GUI, the API, the CLI, and we have a distributed data plane. So one thing that's unique about this data plane is the default mode of behavior is active-active. You would have to intentionally configure it to be active standby. The default is active-active. So that means a lot of the scaling challenges you might have with a traditional load balancer are overcome because you can scale out by just adding more active load balancers. So instead of a model that you may be used to where you manage a bunch of different load balancers, maybe you have some manager of managers over the top, kind of further complicating that architecture, what we have is a central management point that is the interface for your load balancers. And then beneath that is a load balancing fabric, an application services fabric that can scale elastically and that can be deployed across multiple different infrastructures. So that can be a public cloud, that could be an on-prem environment, it could even be front-ending your Kubernetes clusters. It's also what allows us to scale and upgrade and migrate a little bit more efficiently than you might be able to with a traditional active standby pair, allowing us to integrate really well in high performance scenarios in public cloud environments without having to face some of the feature restrictions that you will hit when developing a more complex application delivery tier for your web applications in some kind of public cloud environment. Thanks, everybody. I hope this was helpful for you. You know, I've gotten hands-on with basically every load balancer out there. F5, and HA Proxy, Kemp, Nginx, all the public cloud load balancers. I've gotten to use all of them To me, Avi still clearly stands out as the preferable solution in my book. But I'm interested to hear from you. So if you have any thoughts on this subject, whether it's an agreement or a disagreement with anything I've said, I'd love to get your feedback. Otherwise, thank you for watching. Like, share, subscribe to the channel if you want more similar content, and happy application delivery and load balancing out there. All right. Bye.